Okay, part 2. I've snuck in an extra example. Just going to look at sketching. So I've changed the domain. This is the same one as from the previous clip, but I've changed the domain to x does not equal 10. If you put 10 in, you're going to be dividing by 0. So that's why we have this restriction. In terms of sketching these, there's kind of quite a bit going on really. We can find x-axis intercepts, y-axis intercepts. What happens as x approaches infinity, and what happens as f of x approaches infinity. So yeah, a bit going on. So let's start with looking at what happens as x gets really big. So as x approaches infinity, f of x, we did this on the last one actually, didn't we, approaches 2 over an infinitely big number. I wouldn't normally write this like this, but 2 over a massive number is going to give you something that approaches 0. If you're ever unsure, you could just put a really, really big number into your calculator and see what happens. So as x approaches infinity, f of x approaches 0. And so we have an asymptote on the x-axis. So as x gets big, f of x is approaching 0. It could be approaching 0 from below or above, but we won't worry about that just at the moment. As x approaches 10, so I'm making the bottom of my fraction 0, then f of x approaches 2 over 0, and that's going to give you something that's infinitely big. So if x is something like 10.00001 and you take 10 away, then you get 2 divided by something very close to 0, which is infinitely big. So to find the asymptotes, you let x approaches infinity to find your horizontal asymptote, and then to find your vertical asymptote, you think about making the bottom of this fraction 0 essentially, and that kicks up a vertical asymptote. These graphs here are all this sort of shape, but they can be orientated differently depending on what's happening within the function, which we'll look at in a minute. Sorry, not that paper. So it's worth finding axis intercepts. So when x equals 0, f of x is equal to 2 over minus 10, which is minus a fifth. So when x is 0, f of x is minus a fifth, which is going to be there somewhere. So this curve here is going to be coming down like that, approaching this asymptote this way, and approaching these asymptotes from this direction. And if you think about it, it's a bit like 1 over x that's been moved right by 10, which gives you the vertical asymptote, and then stretched by 2. That's the first one. Next one, it's the same method, it's just very slightly more difficult. So we'll do the same thing. So as x approaches infinity, then f of x approaches, we can do this method right the way through maths. As x gets really, really big, the fact that you've minused 1 from the top and added 4 to the bottom isn't going to make really any difference to your result. So as x approaches infinity, f of x is going to approach x over 2x, which is equal to a half. So that's your horizontal asymptote. And then to find your vertical asymptote, you set the bottom of the fraction to 0. So as x approaches -2, then f of x approaches infinity. So bottom of the fraction to 0 to get the vertical asymptote. So I know that as x approaches infinity, f of x approaches a half. And as x approaches -2, then f of x approaches infinity. So there is a domain restriction on here that x can't be -2, which I didn't write in because we can't actually divide by 0. Y-axis intercept is when x equals 0. So when x is 0, f of x is -1/4. And then if f of x equals 0, so that would give me that's like setting y to 0, so that would give you your x-axis intercept. If you've got a fraction that equals 0, then if I times by that denominator, I'll just get x minus 1 equals 0, and so x is equal to 1. So to find where a fraction equals 0, you set the top to 0. And so I'm crossing here at 1 and here at -1/4. And then I have an asymptote coming up through here. Sorry, it's not they're quite hard to draw. So that's coming like that, and then that will get reflected up like that. You don't totally need to know that. Sketching that. To find the inverse of f of 5, you can think about your mappings. So f of x maps x onto 5, or if it does, then the inverse will map 5 onto x. So to find the inverse of 5, I can actually let f of x equal 5, and then that becomes an algebraic exercise. So x minus 1 over 2x plus 4 equals 5 times by the denominator. And then that's 10x plus 20, and then I end up with 9x equals minus 21. So x is minus 21 over 9. So you're really kind of saying what value of x makes f of x equal 5, and then the inverse takes you back. To find the inverse of f of x, you need to swap x's and y's. So you get x equals y minus 1 over 2y plus 4, and then I need to make y the subject. So it's the same bit of algebra you saw last week, times by the denominator with the logarithms. Then I need to multiply this out because I've got y on both sides. Then you need to take the y's to one side and everything else to the other side. Then you take y out as a factor. And then you divide. So you really need this bit of algebra. You might decide there's too many negatives in there, and then you can times top and bottom by -1. So that'll give me 4x plus 1 over 1 minus 2x. Just looks a little bit neater, but that's not incorrect. So I need to times by the denominator. Got y's on both sides, so I need to multiply out, collect the y's on one side, everything else on the other side, take y out as a factor, and then divide